Hello, good afternoon, everyone. So we'll start today, start for the day. Good afternoon, everyone, and a very warm welcome to all of you. On behalf of RUA Ecospaces LLP. Hello, good afternoon, everyone. So we'll start today, start for the day. Just a minute. Sorry for that. So, good afternoon, everyone, and a very warm welcome to all of you. On behalf of RUA Ecospaces LLP, I am delighted to welcome all of you to today's Knowledge Series webinar on wastewater managing and treating wastewater for sustainable urban development. I am architect Lekha Vishwas Khairnar, green building analyst with RUA Ecospaces. Sorry for that. So, good afternoon, everyone, and a very warm welcome to all of you. Before diving on behalf of RUA Ecospaces LLP, I am delighted to welcome all of you to today's Knowledge Series webinar on wastewater managing and treating wastewater for sustainable urban development. I am architect Lekha Vishwas Khairnar, green building analyst
Ma'am,
with
your
RUA.
voice is
Sorry for
echoing.
that. So, good afternoon, everyone, and a very warm welcome to all of you. Before diving on behalf of RUA Ecospaces LLP, I am delighted to welcome all of you to today's Knowledge Series webinar on wastewater managing and treating wastewater for sustainable urban development. I am architect Lekha Vishwas Khairnar, green building analyst
Ma'am,
with
your
RUA.
voice is
Sorry for
echoing.
that. So, good afternoon, everyone, and a very warm welcome to all of you. Before diving on behalf of RUA Ecospaces LLP, I am delighted to welcome all of you to today's Knowledge Series webinar on wastewater managing and treating wastewater for sustainable urban development. I am architect Lekha Vishwas Khairnar, green building analyst
Ma'am,
with
your
RUA.
voice is
Sorry for
echoing.
that. So, good afternoon, everyone, and a very warm welcome to all of you. Before diving on behalf of RUA Ecospaces LLP, I am delighted to welcome all of you to today's Knowledge Series webinar on wastewater managing and treating wastewater for sustainable urban development. I am architect Lekha Vishwas Khairnar, green building analyst
Ma'am,
with I'm so sorry, I have no idea why was there an audio issue. I'll restart the whole thing. Good afternoon, everyone, and a very warm welcome to all of you. On behalf of RUA Ecospaces LLP, I am delighted to welcome you to today's Knowledge Series webinar on wastewater managing and treating wastewater for sustainable urban development. I'm architect Lekha Vishwas Khernar, Green Building Analyst with RUA Ecospaces, and I will be your moderator for today's session. Before diving into our main session, I would like to briefly introduce you to RUA Ecospaces. RUA Ecospaces is a multidisciplinary consultancy specializing in sustainable architecture, green building design, environmental audits, green interiors, and capacity building. Founded and led by Dr. Roshni Udyavar Yehuda, who has over 2 decades of expertise, we help in creating resource efficient and humane spaces that combine global best practices with local context. We specialize in green building design and certification, providing end-to-end green building design and certification services including LEED, IGBC, GRIHA, ASSOCHAM, GEM, and EDGE. ECSBC certification. We are an empaneled organization for ECSBC certification, supporting energy efficient and code compliant design. Green and energy audits. We conduct green and energy audits as an ISO 17 or 20 2012 accredited Type A inspection body by NABCB and QCI for green audit. Green interiors. Our green interior solutions focus on human-centric, healthy, and environmentally responsible spaces. Training and capacity building. We offer we offer workshops, technical training, and capacity building programs to promote sustainability awareness and expertise. MSME and Z certification. We assist in industries we assist industries in achieving MSME Z certification to enhance quality, efficiency, and sustainable manufacturing practices. Ultimately, our vision is to create resource efficient, climate resilient spaces that foster true ecological balance. We have had the privilege of bringing this vision to life across a very diverse portfolio, from hospitals like Dr. L.H. Hiranandani Hospital, which achieved LEED Platinum and ranked among 10 LEED hospitals in the world, Agrocell Industries in Bhuj, Gujarat, high-rise residential projects such as Nahar Excalibur in Mahalakshmi and Sri Vasundhara CHS in Navi Mumbai, and international projects like Heartland International School and North London Collegiate International School in Dubai. Our sustainable community initiatives include the rainwater harvesting, eco hub, and hydroponic system at the SVT College Zoo. We are incredibly excited to bring some of that sustainable design insight into our discussion today. Thank you all for joining us. So, water. Water is among our most essential resources, yet it is becoming increasingly scarce and unpredictable. Cities worldwide are grappling with water stress driven by urbanization, population growth, pollution, and climate change. Closer to home, India is already feeling the effects. This year, several regions of Maharashtra, including Mumbai, experienced delayed monsoons, raising concerns about reservoir levels and long-term water security. A reminder that fresh water cannot be taken for granted. As architects, planners, engineers, environmental professionals, industries, institutions, and citizens, we all have a role to play. Wastewater treatment and reuse are no longer optional. They are essential to resilient and sustainable urban development. Today's webinar explores how modern treatment technologies, innovative solutions, regulatory frameworks, and best practices can help us move towards a future where water is conserved, recycled, and reused responsibly. We are honored to have esteemed panel of experts joining us today. We also have a question and answer session towards the end of the webinar, so we encourage all participants to post their questions in the chat box. Moving on to our first speaker for the day, Dr. Roshni Udyavar Yehuda. She is a practicing architect, academician, and sustainability expert with over 20 years of experience in the energy efficient and environmental design of buildings. She is the CEO of RUA Ecospaces LLP and Roshni Udyavar and Associates, and is a certified master trainer and empaneled expert on the Energy Conservation Building Code (ECBC) by the Bureau of Energy Efficiency, Government of India. She has contributed extensively to green building research, policy, and sustainable design initiatives at both national and international levels. With that context, let's begin today's session with someone who has dedicated her career to advancing sustainability and resource efficient development. I would like to now invite Dr. Roshni Udyavar to deliver the opening remarks and set the stage for today's discussion. Roshni ma'am, the floor is yours.
Thank you, Lekha. I hope I'm audible.
Yes, ma'am.
Yeah.
Yes.
So, good afternoon and welcome to this knowledge session series that RU Ecospaces has been organizing for the last maybe 2 years or so. And this subject, especially, is quite close to my heart because wastewater, as in water, we have worked in a number of water related projects, whether it is the Dahisar River Restoration Project or the Jezuri Lake Restoration Project, Charlotte Lake in Matheran. So many different projects we have worked on, and all of them involve the aspect related to wastewater. So this is a very important subject, as Lekha has already mentioned to you. We were all afraid just before the monsoons. Now that it has arrived, we were all, quite scared that what if there is no water. So water and wastewater are very important subjects. Uh, well, today's subject is about management of wastewater, especially in the context of urban areas. So, wastewater, in fact, it does not exist in the natural world. If you go to the Amazon rainforest or any other forest, there we will not find any gutters or nalas, and there is no wastewater at all. We only have a life-giving forest, and in forest everything is cyclical. It just goes back in a cycle in all of nature. And what we see there is a hydrological cycle, which is beautiful, which gives birth to life. Whereas what happens in cities, in metropolitan cities, this is a process very typical to human settlements. In metropolitan cities, the sewage or wastewater is collected, it is gathered together, centralized, and treated to be sent, after treatment to natural water bodies. However, due to the large number of illegal settlements and slums, nalas are often seen in large cities, whether it is the Methi River in Mumbai, which, almost becomes a nala, as all other rivers, whether it is Pune, Mulla Mutha River, or any other river. We see that they ultimately have become nalas, or the Buckingham Canal in Chennai. In all of these places, we see that. However, the problem is worse still in the peri-urban areas or the small towns or the upcoming towns. As in these cases, what happens is the settlements come up informally, and sewerage, which is either black water or gray water, is just left somewhere and maybe ends up in some common public spaces, becoming a source of disease and infection. So, this is an issue that is what we want to discuss today, and some of the people here are going to talk about technologies as well as Dr. Shalini. I'm so glad she could join. Has worked a lot on the particular technology that NIRI has developed, and so there is no dearth, in fact, of wastewater treatment technologies till date. I mean, there are n number of technologies and wide variety which can be applied to different types of buildings. And it is not possible to cover all of these types in a webinar of this small, in this smaller webinar. However, what we have done is to put together experts and technologies who have something which is working more in tandem with nature. So I hope that we all have some takeaways that we can at least adopt some of these technologies wherever possible. And I know that there are friends here from universities who had contacted me yesterday as to what can we do, beyond this webinar. It's okay to do a webinar, but what beyond that? So I'm sure that we will be able to take up some projects related to especially wastewater. I've been talking to Dr. Shalini also about this as to how we can do this in small towns. We can, design the landscaping as well as wastewater treatment technologies. So with that, I leave it to the experts to guide us and to take us through the whole range of techniques and technologies related to wastewater. And again, a warm welcome to all of you, especially the speakers. Thank you for taking the time. And back to you, Lekha.
Thank you, Roshni ma'am, for that insightful overview and for setting the stage for today's discussions. Before we start, please be informed that if you have any questions, you can put in the chat box and it will be addressed at the end of the session. So our next speaker is a distinguished scientist and a researcher from one of India's premier research institutions. It is my pleasure to introduce Dr. Shalini Tandon, principal scientist at the Mumbai Regional Center of CSIR NEERI. Dr. Tandon holds a PhD from ICAR, the Indian Agricultural Research Institute, IARI, and has dedicated her career to advancing environmental research and sustainable solutions. Her journey, her research journey spans soil, water, air quality management, providing her with a comprehensive understanding of environmental systems and their interconnections. For past 20 years, she has been associated with CSIR NEERI, where she has worked extensively in the areas of water and wastewater monitoring, remediation technologies, phytoremediation, and bioremediation. Through her research, technical expertise, and contributions to the environmental science, Dr. Tandon has played a significant role in promoting innovative solutions for water quality improvement and environmental sustainability. Today, she will share her valuable insights on wastewater management, treatment technologies, and the critical role of science and innovation in building a water secure and sustainable future. Ma'am, we are really honored to have you with us today. The floor is yours.
Thank you, Lekha, for a very nice introduction and welcoming me. And thank you, Dr. Roshni Udeva. Thank you so much. Am I audible?
Yes, ma'am. Yes, you're audible.
Okay.
Yes.
Yeah. Okay. So I'll start now. I am Dr. Shalini Tandon, working as a principal scientist with CSIR NEERI, National Environmental Engineering Research Institute. I have the headquarters of NEERI is in Nagpur, and I'm working in the Mumbai Regional Center of NEERI for the past 20 years. And this is my email ID, official email ID. Today, I'll be talking to you about phytoremediation of wastewaters. Next slide, please. Why do we need a phytoremediation system for treatment of wastewater? There are a lot of advantages to it. First of all, we don't require any power. There is indirect cutting on CO2 emissions. Plants take up carbon dioxide. Extensive engineering structures are not needed. Highly skilled personnel are not needed for running the system. And harvested plants can be composted. Wastewater serves as a liquid fertilizer. Nutrients go back to the plants, skipping the step of contaminating the natural water resources. If land is an issue, is a constraint, then design a system that would require less land. That is possible in this. It becomes a part of the existing green area. Next slide. Next slide, please. Now, how a wetland works. A natural wetland, it serves as a natural biofilter. So if a stream of water which carries sediments and nutrients, it moves into a wetland system, there the sediments will settle down and the nutrients are taken up by the plants, which aquatic plants like rooted emergent plants, submerged plants, floating plants, all of them take up the nutrients. And the stream that flows out is much more cleaner. So what we are doing is we are just mimicking this natural biofilter in an urban and a rural setting. Next slide, please. Now, role of wetland plants. Wetland plants are natural cleansers. So, what we use are wetland plants which are rooted and emergent. Now, these plants have an aerenchymatous tissue, which is an air space system within the roots and the shoots of the plants. Now, this functions like a reverse chimney. It carries oxygen, transports oxygen from outside atmosphere via the shoots to the roots for root respiration, and the gases which are generated in the media are transported via the roots to the shoots to the outside atmosphere. So that is why we need to select wetland plants for remediating wastewater. Nutrient uptake is governed by the rate of respiration of the roots, so selection of plant species is important. The root structure, more extensive the root structure, the more is the rhizosphere area, the more is the interactive area, and more cleansing will happen. Next slide, please. So there are various wetland plants that can be used, which are locally available. There is elephant ears, colocasia, we have palm umbrella, we have cattail, scanner, spider lily, cypress, scripus, many. Whatever is available locally should be used as it is adapted to the local climate. Next slide. Now, hydrophytes, getting to a little in depth of it, hydrophytes have special characteristics, especially those plants which are submerged and they are floating plants. They have a thin cuticle, stomata are open most of the time. They have large number of stomata on either side of the leaves, and they have a less rigid structure because of the water pressure which supports them. They have flat leaves for flotation. Air sacs is a very, very important feature, and they have smaller roots because they don't need roots to take up water, deeper roots to take up water. So, so these plants have a special characters which make them suitable for remediating a wastewater system. Next slide, please. Okay, so I'll be talking about two types of engineered wetlands: surface flow engineered wetlands and subsurface flow engineered wetlands. Now, surface flow engineered wetlands have a soil or a gravel bed, and the wastewater flows along the surface, allowing settlement of solids and coming into contact with the bacterial population, microbial population on the surface of the media and the plant shoots. So, the lower part of the plant shoots is in contact with the wastewater that needs to be treated. So as it passes through this, it gets cleansed and we get a much cleaner water in the outlet. Next slide, please. The second is the subsurface flow engineered wetland system. Here, the wastewater flows through the soil or gravel bed media and comes in contact with the microbes on the roots and on the media. An inlet zone of large media ensures influent liquid is distributed effectively into the media, and a similar outlet zone collects the treated liquid in a drainage pipe. So, in this case, you can't see water flowing over it. Everything is happening beneath the surface. So, the advantage is that a larger volume of wastewater is being exposed to the gravel bed or the soil bed and the plant roots. So efficiency becomes much more higher. Now the basic, next slide. The basic units are a sedimentation tank, a planted bed, and a treated water collection tank. In sedimentation tank, here the wastewater is collected and the suspended settleable solids will settle down, and the overlying wastewater having dissolved organics will be transferred to the planted bed where you have emergent rooted wetland plants, a gravel bed system. As it passes through it, the nutrients are taken up by the plants. The microbes will act on the organic matter and converted into nutrients in the plant available form, and the treated water then moves out into the collection tank. Next slide, please. This is the planted bed, which has graded gravels and baffles. Now, these baffles actually provide a sinusoidal movement of wastewater through it. So, when the wastewater enters the system, it goes vertically down, then it flows horizontally, then vertically up. And like that, in a smaller surface area, we can have a higher treatment time. Like the footprint reduces. And as the water passes through it, it interacts with the roots, the microbes, and the plant will take up the nutrients. The microbes will act on the material, will convert different forms of the plant nutrients into available forms, organic matter nutrients into available form and are taken up by the plants. And likewise, the water that you get from the outlet is much more cleaner, has much lower COD, BOD, even the fecal coliforms is less, and the nutrient level is also less. Next slide, please. So I've been working on phytoremediation and bioremediation for a number of years, and a lot of research papers are there, a lot of work I have done. And now in this webinar, I had to select what to show you all. So actually, I've selected only two, three things which I have done in this presentation. So this is a phyto bioremediation system, and this work was on methane emission potential and increased efficiency of a phytoremediation system bio-augmented with a bacterial species. Now, this bacterial species I had isolated from municipal wastewater, which was being treated in a engineered wetland, and from there only I isolated it. And in the horizontal subsurface flow constructed wetland mesocosm, we did the study on the mesocosms, which are designed to treat municipal wastewater, were bioaugmented with Bacillus firmus. The efficiencies of the mesocosms were assessed. We had a non-vegetated mesocosm, a mesocosm, or the constructed wetland with scrippish wetland species, and the third one was with Bambusa vulgaris, and they were assessed. We found that bioaugmentation not only enhanced the efficiency of phytoremediation, the cleansing capacity of the system, but also reduced methane emission from the planted mesocosms. Next slide, please. And then the another study was optimizing the use of a bacterial species for treatment of municipal wastewater. A bacterial strain was isolated again from municipal wastewater. The isolated strain was used for treatment of sewage in system one, where aerobic system was provided with external aeration, and it was also immobilized. It was immobilized as calcium alginate beads, and later on, I immobilized it on polyurethane foam also. And we got a higher, around 50% higher BOD and COD removal over the non bioaugmented systems. Now, immobilization becomes important because each time you don't need to add fresh inoculum, it doesn't come out into your treated effluent. So that becomes easier. And also in the immobilized form, they are more resistant to stresses, more resistant to toxic substances and antibiotics if they are present in that water. Next slide, please. So the system two consisted of an upflow aerobic reactor without an external aeration. And we found with 10% inoculation, the removal of BOD and COD was 30% higher than in the non-bioagmated system. Then, next slide, please. Then the third study was on removal of chromium. You know that wastewater has heavy metals also. Like it's a big, big problem. And we did a study on Ochrobacterium sud intermedium, where I isolated this also from municipal wastewater for the removal of hexavalent chromium through different immobilization techniques. And chromium 6 is one of the toxic heavy metal which persist in the ecosystem. And heavy metals cannot be degraded into non-toxic forms, and they continue to create serious global health concerns. A bacterial strain isolated, identified as Ochrobacterium suriintermedium, was found to be tolerant to concentrations of chromium 6 up to 600 milligrams per liter in nutrient media. Calcium, alginate, and polyurethane foam were two different materials used for immobilization. And at a higher inoculum concentration of 5%, removal of chromium 6 increased, showing 80 to 86% removal by calcium alginate and polyurethane foam method. Why I'm telling you this? Because if we have certain specific bacteria which are efficient in removal of particular contaminant, we can immobilize it on the media, in the support media. And we can use that support media as a bed material in a phytoremediation system. So as the wastewater passes through it, like with the plants which are selected plants that we are using, and the wastewater will get cleansed more. That particular contaminant will be removed more efficiently. More efficiently means if it takes, say, 2 days for it to be cleaned, it can be cleaned in, say, 12 hours. And it will be cleaned. If you just use it randomly, then any biofilms will be formed of all different kinds of bacteria on the media. So that removal efficiency of the contaminant will be much lower. And now, like, how why phytosystems are so important, like when we compare it with the conventional treatment systems, the percentage of BOD removal is highly comparable. And in a phytosystem, you won't find sludge formation, which is there in other systems. We don't find sludge formation. And then equipment requirement is also minimal. And in case of operational things, we don't need a skilled operator to maintain it. Even a gardener can look after the system because it integrates into the landscape. And it can be designed in a manner that the water flows under the effect of gravity. So you don't need power to actually push the water through. And so no power requirement is there. So actually this there are lots to talk about it. There's a lot of research that has been done. NIRI has developed this technology, and they're using it at different places. And if you want to know where all it has been applied, you can contact NIRI headquarters, NIRI Nagpur Business Development Unit, and find out where all this technology has been used. And if and those who are interested in phytoremediation and integrating bioremediation with this, you're most welcome to get in touch with me. My contact details are there with Dr. Roshni Udyawar. And also my email ID was there from the first slide. You can contact me. We can have a discussion and we can come out with something more applicable. Thank you so much.
Thank you, Shalini ma'am, for that highly informative and insightful session. Do we have any questions for Shalini ma'am? Okay, so I don't think so as of now. You can put it in the chat box if at all.
Yeah, and
Uh,
also, yeah, if like, after the presentation, if there's an afterthought or anything, they can get in touch with me and we can have one-to-one meeting. And also they can write a mail to me and I can clarify more things to them, because there's lots to discuss, lots to know. And it is, we should apply it, and it will help the society. Yes.
right. We have one question. At what scale is this applicable?
It is applicable at very larger scale also. We can do it for societies. Um, See, actually, the rule is for 1 cubic meter of wastewater that needs to be treated, you need 2 square meters of area. So this is a very general rule, and you can design it depending upon the area that is available. You can make it more deeper, shallower, and the kind of terrain is there, so it can be designed accordingly.
Right. Okay, that's it. Do we have any other questions? Yes, ma'am, there are questions in the chat box coming up for you.
Can we have entity discharge norms with this system COD5? Yes, we can. If you have a primary treated wastewater, so it can come down to this level. If you design it in a way, it is achievable. But this water which is there in the outlet, it is not for potable purpose. It is not for potable purpose because it will contain coliforms. Although fecal coliforms are reduced to a very high level, but still they do exist. So it can be used for gardening. It can be used for washing, cleaning, that purpose. But I suggest after the outlet water, should also do some kind of ozonation, chlorination to disinfect it. What is it?
Anybody else?
Please share the contact information for details.
Detail.
Okay, so you can also contact me. My all contact details are there with Lekha. And also, if you want to know wherever this has been applied, then please go through the NEERI website and contact the business development unit, and they will tell you where all this particular technology has been used. And also, NEERI has developed an upflow system for STP system that has been invented by Dr. Ritesh Vijay in Niri Nagpur. So you can also contact him and find out what he has done, and you can also apply it. You can connect with him as well.
Okay.
Yeah, that's
The
it.
ID in the
Thank you,
chat
Rekha.
box. If anyone
Yes.
requires, you can take it from there. Okay, great. Thank you so much, Shalini ma'am.
Thank you, Lekha. Thank you so much. Thank you for inviting me.
Yeah. Okay, so our next speaker for today is Mr. Mandar Prabhune, technology head at Transchem Technology head at Transchem Agritech Private Limited. So, Mr. Prabhune is an environmental scientist with over 3 decades of experience in environmental management, wastewater treatment, solid waste management, and analytical sciences and sustainable development. He has been actively involved in developing innovative environmental technologies, including the biofilter wastewater treatment systems, groundwater treatment solutions, microbial cultures for waste management, and environmental testing technologies. Over the years, he has successfully worked on numerous wastewater treatment projects across various sectors, including the domestic, industrial, pharmaceutical, petrochemical, and other industries. His expertise spans technologies such as ASB, MBBR, SBR, MBR, reverse osmosis, nanofiltration, ultrafiltration, and biofilter systems. He's also a visiting professor, mentor, researcher, and active member of several environmental and water management organizations. Today, he will share his extensive experience on sustainable wastewater treatment technologies, resource recovery, and practical approaches to the environmental management. Sir, it's a privilege to have you with us today. Over to you.
Thank you, Lekha. Extremely thank you for your introduction and also inviting me today for this webinar to discuss the subject on the urban wastewater sustainable waste management. So I'm just trying to uh, share
Yeah.
the presentation. So is it visible?
Yes, it's visible. You can do it full screen.
Okay.
Yes, sir. It's visible.
Yeah, it's visible. Huh? Okay.
Yes. Thank you.
Okay. Good afternoon, everyone. So, Roshini has set a good tone in the beginning regarding the main objective of organizing this webinar to understand actually the managing and treating of the wastewater for sustainable urban development. Now, when we talk of any wastewater, it is very important for us to understand the uh, sources of. I'm not able to. So it is very important for us to understand the various sources of wastewater. So any kind of human activity generally generates the domestic wastewater. So maybe it would be from the household activities, from the institutions, from hotels, from corporates, from industries, from everywhere, wherever we have any human activity, the wastewater generation is going to happen. So whenever we generate this kind of wastewater, it is very important for us to understand what are the different characteristics of wastewater. Because unless we don't understand the characteristics, it will be very difficult for us to design any kind of a treatment system. So if we just have a look on the basic characteristics, so mainly the domestic wastewater, which is coming from the household uh, sources, basically contains almost 99.5% of water and only 0.05% of suspended solids. Now, these suspended solids are the biggest threat to the environment because it contains the human waste, the residuals of the food what we generate from the household activities. There are certain kinds of chemical contaminants which comes mainly from the use of detergents, from various medicines and other extra personal care products. All those comes as a excreta out of our household activities. So if we want to design any kind of a treatment system, we need to understand properly the wastewater characteristics. And though it is having 99.5% of water, the biggest challenge is to handle this 0.05% of solids because that is the basic contamination which contains lot of pathogenic organisms which are directly harmful to the environment, not only to the environment but also it can pollute our water bodies, and these water bodies when they get polluted, and that is the reason we are not able to get the safe drinking water which is the requirement of the today. So what is a sewage treatment plant? So any kind of a facility or a process where we can treat the sewage is basically known as a sewage treatment plant. And so like we have industrial effluent treatment plants, in when we talk of domestic wastewater, we call it as a sewage treatment plant. So the sewage treatment plant can be established at various levels, maybe at the town level, at the city level, or in the urban, rural areas, or in various industries, hotels, institutions, colleges, schools, etc., from wherever it is generated. So why do we need to have a sewage treatment plant? So basically to protect our water bodies like rivers and lakes, to prevent the water pollution, to protect the human health. And of course, if we try to treat this, then definitely this water can be reused back. So that is the reason we need a proper, well operated and well functional sewage treatment plant so that whatever wastewater which are generating, because when we talk of characteristics, then I told you that 99.5% is water. So if we are able to reclaim this water after proper treatment, the whole 99% of water can be recycled back. And the recycling can take at various places. It can be used for various applications like gardening, for landscaping, for toilet flushing, to be used for industrial applications. So there are a number of applications are there where we can use this reclaimed or the reused water. So basically these STPs, basically they remove the organic matter, the solids, the pathogenic organisms which are mainly harmful to the environment, and other pollutants are treated in the sewage treatment plant. There are various technologies which are available to treat sewage treatment. So the conventional methods like MBBR or SBR or MBRs are the latest technologies where we can treat the sewage treatment properly. Also, there are certain green technologies and natural systems like constructed wetlands. Dr. Shalini also just mentioned about the phytoremediation. So phytoremediation also is one kind of a constructed wetlands. We also commonly it is known as root zone technology or the phytoreed technology. Similarly, we have a biofilter technology which we have developed since last 10, 15 years. And after studying various technologies, the limitations of that, we have tried to develop such a technology which is able to take care of all the limitations of the other systems. So basic requirement today is of decentralized sewage treatment plant because we know uh, when we talk of the centralized STPs, there are a number of challenges and limitations to handle a huge quantum of sewage which is generated and is transported from one place to another. So it not only cost much, but also it allows lot of leakages in the system, in the sewerage system. So that is the reason there is a pollution on the land also, and when it comes in contact with the water bodies, it contaminates. So it is always better to treat the sewage at the source. And when we talk of at the source, then the decentralized or the smaller systems comes into picture. So if you want to really reuse the water, the decentralized systems will be much more better to handle also in terms of the volumes and of course you get recycled water there itself. So there are a number of advantages if we can plan properly decentralized STPs, and more or less in various in many of the regions there are no properly laid sewerage lines. So that is the reason you see the pockets of wastewater like in small ponds or some kind of ditches which are there, and there the treatment is not happening, and that is the reason we face the water pollution issues. So if we really want to uh, reduce the issues of wastewater, definitely we should think of decentralized systems, and particularly like a country like India, the decentralized systems are much more effective than the centralized systems. So here today I will be talking you about the biofilter technology which we have developed since last 10-15 years. And basically the idea is to develop such a technology which is much more user friendly. It is completely green, and that is the reason our concept is design with nature. So that how the best the natural system works, but definitely we have taken also certain scientific learnings from the modern science, so that combining both the natural and the science, we are able to get a very effective treatment system. So basically, the biofilter system basically utilizes the ability of the earthworms and beneficial microbes. So basically, we have developed specialized microbial cultures known as transzyme, where the organic waste is broken down into the harmless components into available nutrient forms. So here the main processes takes place, which are mainly the adsorption, the filtration, and the biological degradation. Here we use specialized media, which is completely organic in nature. So the main function of media is to adsorb the suspended solids which are present in the wastewater. Unlike in other systems where you require a sedimentation process earlier, in our system there is no requirement of sedimentation. All the suspended solids which are present in the wastewater acts as a food for the earthworms, and in turn earthworms digest those suspended solids and convert into good compost and generates millions of beneficial microbes which are mainly required for the biological degradation process. Recently we have also got the patent on this technology, so our Indian patent number is also mentioned in the presentation. So if you see the comparison between the conventional STPs and biofilter system, you can see in conventional there are a number of unit operations. Like you require primary sedimentation tank, the aeration tanks. Then after aeration tank, you require clarifiers, and then the disinfection system. While in biofilter system, it is one step reaction or process where you don't have to require a sedimentation tank. Directly the wastewater can be just you have to put a strainer which can take care of the non biodegradable material like plastics and some other glass or metal parts which are removed through the strainer, and only the biodegradable wastewater can be treated through biofilter system. So in one step you are able to treat the sewage, and it's a continuous process, and the retention time is just 45 minutes to 60 minutes to treat the water. And of course, the advantages are like it requires very low energy. There is not much maintenance required because there are no any mechanical equipments. We don't require any aeration system or diffusers to be installed in the system. And as there is no sedimentation tank required, the sludge is not generated. All the solids are converted into good compost, and they are having very nutrient-rich components inside the compost, which are directly can be used for as a fertilizer, as a solid fertilizer for landscaping, or even can be used for agriculture purpose. And it's completely aerobic, and there is no odor in the system. So as I mentioned you, it generates nutrient-rich water, vermicompost, and earthworm biomass. There are no chemicals added in the process, absolutely low maintenance and low energy input, as there is no any mechanical equipments used. No unhygienic sludge disposal required because all the suspended solids are converted into good compost. There is no odor, no noise in the system, very less HRT time in comparison to the conventional system, and can be implemented at decentralized level with economy of scale. So these are some of the models which we have installed at various places. So we have modular plug and play systems. We have civil based plants. We can also provide you solar based system where completely it becomes green technology, and though no external power is required, all the power can be generated through solar system. It can be also designed in the form of a greenhouse kind of a system. So based on the geographical locations and site conditions, the design can be made. See, these are some of the modular systems which we have installed. So right from 5 kLD to 1 MLD systems, we can design based on the requirement. These are all compact modular plants. This is one of the systems which we have installed in one of the ITIs in near Vadodara in Gujarat. So it is just we have made a stone pitching tank, and inside that we have filled the media and the required cultures. So depending upon the locations and site conditions, the designs can be made. In one of the villages also we have installed these systems where the rural wastewater can be converted into usable water and is used by the farmers for agriculture purpose. So this is the plant which is installed in a rural area in one of the government schools. So where students are also studying there, and you can find it that just in adjacent to the school we have installed the plant. That gives the basically kind of confidence that there is no order generation or any no nuisance value of the sewage treatment system. The capacity of the plant is around 120 KLD. One of the other plant which was been inaugurated by the Chief Minister of Gujarat, of course now he is no more Mr. Vijay Rupani, but he inaugurated this plant in 2019. That is also 100 KLD plant in rural areas. So one of the important aspect of biofilter system is that it is kind of a resource of nutrients. So whatever nutrients we have in the sewage can be converted into available form. So like nitrogen, phosphorus, all these are good nutrients available to be used as the nutrients. So if we try to use this water in rural areas for agriculture, definitely there will be much reduction of the chemical fertilizers and you can get better yield. And also the soil conditions can be properly maintained. So these are some of the practical applications of the wastewater where farmers have used this water for rice crop plantation. And also in the bottom, you can see the banana plantation, which has been developed with the use of reuse of this water. The banana plantation was, this project is in Chiplun in Maharashtra. So we have one another plant of 100 KLD in Krishi Vigyan Kendra in Jalna, Maharashtra, where the plant is solar based. So it is a 100 KLD plant. The source of water is from the nearby Nala, and it is treated through biofilter system. And then in their model farm, they are using for cultivation of various grass species. And Jalna being a very water stress area in Maharashtra, this is kind of a good kind of a reuse water they are able to use. These are also some of the other installations in Aurangabad where farmers are using this water for growing of vegetables and other horticultural plants. And even we have also installed a post RO system where you can further purify this water and can be used for even for other applications like for flushing or for industrial application. So this is a kind of resource generation or the nutrients you can get from this water. So if you have a capacity of around 100 ml, 100 KLD or to 1 MLD, you can get up to around 14 tons of nitrogen. So 28 tons equivalent to 28 tons of urea, 4 tons of DAP and 12 tons of potash. So you can imagine what kind of nutrient availability this water can give you if you properly manage the system. And all these kind of fertilizers can be used for irrigation. And against that, you can reduce the use of chemical fertilizers. So till date, we have installed more than 250 installations. Now, I think recently we have completed almost more than 300. So right from 1 MLD to 50 KLD of various sizes we have installed at various places on pan-India basis. We have received various awards for this technology from various institutes like ASOCAM, we have also received Scotch Award, from FICCI, also recently we have received an award. So various for the best technology awards also we have received, which has been cited here. Thank you so much. So if you want to contact, I have given my contact details. So you can very well contact me anytime for any further information required. Thank you so much.
Thank you, Mandar sir, for that enlightening presentation and for sharing your vast industry experience with us. Do we have any questions for Mandar sir? What is the capacity of biotreatment plants?
So as I told you, we can design a plant from 5 KLD to 1 MLD.
Okay, do we have any other questions?
Yes, sir. We have around 2.5 MLD wastewater.
Okay.
So can it is possible?
Yeah, it can be possible. We can have a modules of 1 MLD.
1 MLD, but our
Yes.
capacity is 2.5 around.
So we can divide the plant into either 2 or 3.
Okay.
Yeah.
ठीक.
So it is
Thank
better
you.
to even maintain also properly.
Okay. How much area is required for bio treatment?
See, for 1 MLD, roughly we require an area of around say 1000 to 1200 square meters.
1000 to 1200 square meter.
Yeah.
Okay.
Including working space.
Including working space.
Yeah.
Okay. Thank you, sir.
Okay, if anybody else has questions, you can put it in the chat box. We can address it later also. So thank you, sir.
Thank you. Thank you so much.
So participants, our final speaker for today is Mr. Saket Ram Vora, Senior Technical Consultant at Plateau Green Tech Private Limited. He represents a company that has been pioneering innovative wastewater treatment solutions with a strong focus on sustainability, operational efficiency, and minimal environmental impact. Plateau Green Tech Private Limited is their unique Aquatron STPs promote environmental sustainability through the instant removal of fecal matter at the source, forming the foundation of their odorless and sludge-free treatment systems, which help in ecological benefits, and it also has a minimal carbon footprint. Since 2018, they have successfully delivered more than 200 STPs across India, serving residential, commercial, institution, and other industrial sectors. Today, Saket sir will share his practical industry perspectives on advanced sewage treatment technologies, operational challenges, and innovative solutions for wastewater treatment and reuse. So we look forward to learning from your experience. The floor is yours. Thank you.
Yeah, thank you, Lekha. As Lekha said, I'm Saket Vora. I'm here representing Plateau Green Tech. We specialize in sustainable water and wastewater management solutions. So I would like to start off by thanking RUA Ecospaces for giving us this platform to share insights about our revolutionizing Aquatron STP technology. I would like to start off by sharing a small video about our technology visually, and then I would like to go on and talk about the sustainable aspects of our technology. Please tell me if the sound is working.
Yes, sir. Yeah.
What comes to
It is working, sir.
when you think of sewage treatment? Sludge, smell, high setup cost, expensive maintenance, unproductive space, and high power consumption? There is a solution for all of these issues. Aquatron, the award-winning, patented, and Green Pro certified instant solid liquid separator, loved by customers worldwide since 1986. Aquatron has made waves both locally and globally with over 15,000 installations worldwide and an impressive 200 installations in India. Aquatron, nature-inspired wastewater treatment, employs a revolutionary approach to eliminate the formation of sludge by instantly separating fecal solids from flushing water. And this is the unique basis for our sludge and odor-free sewage treatment systems, easier STP maintenance, as well as a reduced STP space footprint. The separation process relies on three fundamental natural principles. Momentum of flushing water. The momentum of flushing water is utilized to create centrifugal force naturally. Centrifugal force. The design of Aquatron harnesses centrifugal force to effectively route all liquids to a designated side outlet. Gravity. The force of gravity makes sure that the solids can't get out of Aquatron along with liquids, but inevitably fall in a dry biochamber for natural composting. The first stage of treatment in conventional STPs usually involves recirculation pumps, sludge presses, and so on. But natural solid-liquid separation by Aquatron achieves the same end result with zero human intervention, zero power consumption, and zero maintenance-intensive machinery. And on top of that, Aquatron yields hygienic, odorless manure instead of smelly sludge. In the second stage of treatment, aeration and filtration, Aquatron STPs achieve the same treatment result as conventional STPs, but with up to 75% less power consumption and a fully automated process. This is possible because inlet water quality has already been improved with solid-liquid separation, and there is simply less pollution to treat. Compared to conventional STPs, Aquatron STPs can reduce capital expenditure in tanks by at least 35% and overall operating cost by 90%. Aquatron also minimizes the space footprint of the sewage treatment plant. Aquatron can be scaled up for any capacity from 0.5 KLD to MLDs, and it is suitable for all types of buildings from apartments, villas, high-rise townships, zero-discharge facilities, clubhouses, offices, factories, ashrams, malls and hospitals to educational institutions, resorts, hotels, and so on. Here are some of our clients who are already benefiting from our sustainable Aquatron STPs. WeWork, Gurgaon, Sun Pharma, Halol, Godavari Power and Ispat, Raipur, Sandhya Elite, Hyderabad, Safai International School, Noida, Shantilal Sanghvi Medical Trust Eye Hospital, Mumbai, Grape County Resort, Nasik, Sacred Grove Ashram, Madanpalle, Residential, Modi Spaces, Mumbai, Vura Group, Chennai, Metropolis Gurukrupa Apartments, Bangalore, RNG Infra, Hyderabad. Retrofit solutions are also possible with ROIs as short as 8 months. Treat your wastewater in a hassle-free and natural way. We'll be happy to help you design a solution that's just right for you.
Yeah. So thank you for your attention till now. So I would like to pause the video here. So to summarize what I've shown you till now, I would like to say that most conventional STPs take the same approach of depending on centrifugal action, depending on long retention times and biological treatment to do liquid solid separation, which is the primary stage of any STP process. Whereas the Aquatron STP does it differently. We do it instantly at the source before even the sludge gets to form. And because of this, there are two important advantages. One is the speed of separation, which I would like to show you. So as you've seen, the speed of separation is instant. So due to the shape of the product, the solids fall down, and just due to gravity and centrifugal force, the water comes out from this side. And the second main advantage is the quality of water. Because we're intervening at the source and not after the sludge is formed, the separation process gives rise to a water quality which is 3 to 4 times better even before the second stage of treatment. So as you can see here, as I said, the water quality is already less than 100 at the first STP tank. Whereas in any conventional STP at the first tank at the second stage, you would have 300 to 350 BOD. Whereas I start with a BOD less than 100. So, and another advantage you see with the aquatron chambers are that the solids that are instantly separated are stored in a dry fashion and they automatically convert into manure, unlike conventional STPs where there's a complete sludge management process. So this is another huge sustainable benefit with the chambers because sludge disintegration gives rise to higher electrical requirements and methane and hydrogen sulfide production. Whereas now that we are doing a dry solid decomposition process, we do not produce those gases and we do not require any electricity to do so. Yeah. So to explain why those two advantages, one being the speed and two being the quality is advantageous, is because the speed being instantaneous removes 12 to 14 hours of your daily operation. So your daily operation in any conventional STP is around 20 to 24 hours. So if I'm removing 12 to 14 hours of this treatment, that means the infrastructure required comes down by a minimum of 50%. And then now that I'm removing 50% of your treatment cycle, I'm also removing 50% of your electrical consumption as a minimum. And then I'm also giving you 3 to 4 times better quality of water. So that means your electrical consumption also comes down by a minimum of 55 to 65%. And as a whole, if you look at project to project, I've been able to consistently show a 35% capex saving and a 80 to 90% opex saving with more than 200 successful projects in India and 15,000 worldwide. So now I would like to shift the conversation to today's objective on how the Aquatron STP can contribute towards a sustainable urban development. So many cities, localities, and villages face three main issues. One is overflow and pollution. This mainly occurs during heavy rainfalls in an area where the sewer networks are extremely old or almost non-existent. Second, aging infrastructure. Like conventional STPs are heavily known to be non-versatile. So when you're trying to expand or develop into a bigger and bigger locality, your existing STP cannot take that load. And the third thing is general STPs are all heavily electromechanical dependent. So therefore, when you have any sort of downtime or electrical shut off, all the wastewater, the untreated wastewater that is there, that is directly let into the water bodies beside that locality or city or village. So there are many problems that arise because of this. And the way the Aquatron solve those problems is by intervening at the road level. And further down the presentation, I'll show you how that looks. But now, because as I've shown you before, the Aquatron doing the instant liquid solid separation at the source, these are the benefits that I'm able to provide you. So one being sludge-free water bodies. So as I said, because of the three previous problems, if you're letting go of sludge-filled water into your water bodies, that pollution is a heavy impact on the existing environment in that locality. One, because of your aquatic life. Second, you are effectively removing your sustainable use of or a source of water. Second, many times you are not able to modify your current sewer network or modify your current STP because your sewer networks are now trying to deal with your rainfall, you're trying to deal with solids and liquids. Whereas by implementing the Aquatron at the road level, we're able to completely make your sewer network only for water because the solids are going to be remaining where the Aquatron is positioned at the road. So now traversing and countering like varying terrains and varying contours become extremely easy. And now pumping stations don't require any pumps that have to take care of the solids, which heavily fail. We only require water transfer pumps. So your pipe dias, your networks, your network lengths, and your network sizes all immensely come down. So not only people will open their minds to implement STPs in more localities, we can also implement STPs by combining localities because we don't require the 2 to 3 times space that conventional STPs require. So to go through the benefits, as I said, slush-free water bodies, reduced drainage load, effective decentralization because they're at the road level, and then cost savings of the infrastructure. And to go to the indirect benefits that everyone would benefit from is obviously the reduced waterborne diseases. So if the sludge that goes directly untreated into the wastewater, it is going to develop many harmful bacteria. And if the locals were not aware and go use that water, they're going to develop many diseases like cholera, dysentery, gastroenteritis, etc. And then there are also many positive economic benefits like your land value going up, your water bodies becoming better, that your requirement of treated water being lesser, and as a whole boosting all sorts of ecosystems around you. So this is an example of how the Aquatron can be implemented or retrofit into an existing or a new locality. So as you can see, the red lines are the sewer lines, and these purple, red, and blue boxes can be looked at as the Aquatron chamber, where the Aquatron will be sitting inside a bunker where the instant liquid solid separation will happen. After which that separated water, that high quality separated water now goes to the STP. And this is a very sample example of how a biochamber can look. And as you can see, there are 3 aquatrons sitting down in this chamber. So this is a very specific example because in this road, we have a lot of buildings coming to this one location. And this is where the separation happens. And from here, we take the water to the STP. So apart from all the benefits that I spoke till now, which are the direct benefits, I would like to talk about the benefits to the climate at a massive scale. So one of the main reasons being the size and the costing of the STP for which it's not being implemented. Now that I'm able to solve those issues, if we're able to treat and retrofit the Aquatron throughout India to take care of India's complete sewage problem, we can do it by saving 1.45 million tons of carbon emissions. And the consequence of expanding that 1.45 million is extra methane emissions, water body nitrification, cloud acidification, and climate feedback loops, and many other problems. which are all extremely dangerous for the long run for any human living in that city, country, or region. And this same 1.45 million tons of electricity that is saved can be used to power lakhs of households, thousands of schools, and like thousands of localities. And this is given that after the aquatron, we are doing mechanical equipment as a second treatment. As my previous two speakers have brought up to your attention, there is a solution called the reed bed. And even after the aquatron STP, we highly recommend going for a reed bed solution, because generally another main hiccup in putting a reed bed in many cases is the sizing is massive compared to even a mechanical system. Well, so now, due to the Aquatron STP, where I'm able to reduce a mechanical system size by 3 times, I'm able to reduce the reed bed system size by at least 2 times. So now the reed beds become even more economically viable and also space viable for people trying to implement it throughout India. And these are pictures of different reed bed implementations of ours. This is a 200 KLD treatment at Maharashtra Police Academy. And different looks of how the reed bed can look and also not be an aesthetic burden on your projects. And I would like to conclude the presentation by saying I would like to come back to the roots by saying the solution is always in nature itself. The Aquatron STP, the solution that we have engineered, is a catalyst to bring us back to nature. And as you can see, these are the benefits, as I mentioned throughout the presentation. We are a complete zero sludge system, a zero power system, a zero maintenance system, and there's zero mechanical moving parts. And because of the Aquatron STP, the complete downstream of the STP becomes extremely easier. So after that, whether you want gardening water, reflushing water, drinking water, I can do it all by saving you money and space. Thank you for your time and attention, and I would like to thank RUA Ecospaces again for this platform.
Thank you, Saket sir, for sharing those practical insights and innovative approaches to wastewater treatment. We have some questions for you in the chat box.
Yeah. Okay, so yeah, 1 second. Let me just share my presentation again, because that would help solve one of the questions.
Yeah, sure.
Yeah, so to look at what happens to the solids, if you can see this design, this is more of a top view. I can share the sectional view after the presentation. So each chamber has a partition wall that separates a left and a right chamber, and these chambers are sized so that it takes around 1 to 1.5 years to fill each half of the chamber. So for example, there is a diverter rod diverting the solids to the left side for the first 1 to 1.5 years for the left side of the chamber to fill. So as soon as that side of the chamber fills, now the diverter rod is turned to the right. And now the right side, the solids are falling, and the left side, which is 95% full, is resting. So the thing is, even that 95% of solids do have 1 to 2% of moisture, which are again separated through the walls and the floor of the biochamber, because they have these plastic mats called matala mats. They do a really great job at oil, grease, and water separation from solids. So even after removing the 2%, the 95% of solids that's sitting in this left chamber within 2 to 3 weeks will automatically decompose from 95% to just 5% of manure. And this cycle can be repeated 4 to 5 times, up to which you're able to get around 20 to 30% of manure buildup. And that's when you even have to do maintenance. That's why we are completely almost zero maintenance when it comes to solid management. And unlike conventional STPs, sludge management is a septic process, and you produce septic gases. But we are a completely dry anaerobic reaction, so we only produce carbon dioxide, which is non-toxic and non-odorless, and it's completely hygienic. So this cleaning can just be done with your bare hands or just with a shovel. So that's to explain what happens to the solids, if that clarifies your question. Then the next one. Okay, so can it be implemented at a single building apartment complex? If yes, what would be the approximate cost to install and maintain, assuming a project with 20 to 25 units? Yeah, so the thing is, what my company does, we do an A to Z holistic approach. So we are not just a vendor for the equipment. We do the plumbing design, the civil designs, the complete placement, and we also help with the execution. And we also provide the cost comparison in our preliminary proposals. And all of this is free of cost. And so if I have to retrofit into an apartment like this, I would send my people, or I would come myself, look at the whole system, have collect the drawings and do the design and come back to you regarding the cost. And to answer the question simply, yes, it's possible, but I'll have to come and see the feasibility depending on the space availability and the current plumbing systems used. Yeah. So, but if you're interested in doing it, you can have it in your mind that if compared to any other STP, I'm going to be much lesser in size as possible, at least 3 times lesser. So we would be your best bet if you're trying to retrofit an STP. And all my savings are you can blindly take it as true because we have proved it over 200 times. And for any new project that's coming up, I can guarantee you that I'm going to be able to show you the savings that I've shown you in my presentation. Yes. So how much time does it take for the solid waste to convert to compost? This takes around 2 to 3 weeks once you let it rest. Yeah, so we do not add any culture for the conversion. It is completely natural, just using its own fecal bacteria. The only place we added something is sawdust, and in a very specific installation in Leh Ladakh for the army camps there. So that because the temperature is very, very, very low, to increase the surface area for the bacterial growth, there we have added sawdust. But otherwise, in general climate ranges, it's completely natural. And even the Matala mats that I said that help with the moisture separation, those also increase the surface area, and those holes in the mats act as biofilms for the bacteria to grow. So there's no requirement for any human intervention here. Yes, yes, sir. I will. You said you're interested in a visit, and you can take my information, and I can coordinate that with you. Yes, sir. So the thing is, the Aquatron is a completely modular system. So to give you a tentative cost of a 1 MLD plant, it is completely dependent on project to project, because one Aquatron can take up to 30 WCs, and every 30 WCs will require another Aquatron. So a 1 MLD plant can come from just 5 Aquatrons, or it could come from 50 Aquatrons. So the quantity of the equipment can vary depending on if it being a commercial or residential project. So I have cost comparisons readily available. So I'll get in touch with you after this presentation, and I can share the required information. Okay, so that's a great question. What will be the footprint for a 100 KLD STP? So any conventional STP, depending on your daily output, which is a 100 KL, requires to have a minimum of 1:3 times. So for 100 KL, which is 100 meter cube of tank volume, you require 300 meter cube of holding space to do any conventional STP. For my Aquatron STP, I require only 1:1 times. So 110 meter cube of construction volume. Any other questions?
Great. Do we have any other questions for sir? I think somebody's asking.
Yeah.
Okay. Your contact details.
Okay, I'll just type that in the chat for that. Yeah.
Any further questions? Yeah, we have one question, sir.
Yes, ma'am. So that is a very case specific question. So do we have to make alterations in the existing pipeline? Yes, there could be alterations, varying from complete change or very minimal change, because that depends on what your builder has done in your existing pipeline. Because in India, it's not the same standard is followed everywhere. So I cannot give you a straight answer. But as I said, because my complete proposal period is something I do free of cost. So as I'll share you my details and you can get in touch with me, I will set up the visits required and I'll give you an answer for your questions.
Okay.
Yeah, thank you.
Yeah, I think that's it. Okay, so we began the session with Dr. Roshni Udawar Yehuda, who highlighted the importance of sustainable water management and the growing need for wastewater reuse in urban development. Dr. Shalini Tandon provided us with scientific and regulatory perspectives on wastewater treatment technologies and environmental sustainability. Mr. Mandar Prabhune enriched our understanding with his extensive experience in wastewater treatment technologies, environmental management, and resource recovery. And finally, Saket sir shared a practical industry experience and innovative wastewater treatment solutions that are helping organizations to move forward towards sustainable wastewater management. We really hope today's session has provided valuable knowledge and practical insights that participants can apply in their professional endeavors. On behalf of RUA Ecospaces LLP, thank you to all the participants and the speakers for taking out time and joining us today. A heartfelt thank to our participants for joining us today. And please stay connected with RUA Ecospaces LLP for more such knowledge series sessions on sustainability, green buildings, environmental design, etc. We also request all the participants to kindly fill out the feedback form that has been shared in the chat box. Your feedback will help us improve and conduct more meaningful sessions in the future. Thank you once again, everybody, and have a wonderful evening ahead.
Thank you, Lekha.
Thank you.
There are contact numbers shared in the chats for everybody. You all can take that down, and there's the feedback form also. We'll be sending it through email also, but you can just click over here and share your feedback. Thank you.